Now in the previous lecture, we have implemented direct chaining resolution technique. Now before continuing to the next techniques, let's identify what will happen if the hash table is full. Because when we are dealing with the open addressing technique, we are going to face the issue of hash table is full. So that's why before going to implement them, I'm going to discuss it over here in this lecture. Then we are going to implement this case in our open addressing techniques as well. So the question is, what will happen if the hash table is full? So let's talk about it. Now when we implement our hash function with direct chaining, in that case, the situation will never arise. So in this case, hash table will never be full because in this case, we are adding the references of the linked list to the cells, and then we are adding the new values at the end of the linked list. So let's say we have a hash table like this, and by using hash function, we have found the values of these strings over here. Now in this case, in case of direct chaining, the hash table will look like this. So at the index of 0, we have found this string's value, and we have created a node and added physical location of this node over here. Then at the index of 1, we have this string over here, which is calculated by using hash function. Then it continues like this until n. Now if I want to insert one more element to this hash table over here, in this case we are going to calculate the index using hash function. Then after finding it, we see that it's going to return 1. Now in this case, this is the index of 1. So at the index of 1, we have another string over here. So if we want to add this node at the index of 1, we are just going to create a new node and assign value to it. And we are going to update the next reference of this node to point to this node over here. Now this is how it will continue until the end. So we can add as many as elements in case of direct chain method. So in this case, we don't have any limit. So our hash table will not be full. But in this case, if I have many elements in the linked list over here, the time complexity will become On. Now the next method is open addressing method. Now in this case, whenever hash table is full, we are just creating 2x size of current hash table and recall hashing for the current keys. So let's see how this is working in practice. So here, let's say we have a hash function like this, and we have calculated values of these keys using hash function over here. Now after calculation, we have inserted them in the hash table over here. Now after insertion, we see that we have only 4 cells in our hash table over here, and we have inserted 4 strings to this hash table over here. Now if I want to insert one more string to this hash table over here, we can easily see that this hash table in this case is full. So we cannot insert this string to this hash table over here, because when we are calling hash function for this string over here, it's returning 1, but at the index of 1 we have another string over here. So this means that we cannot insert this string to this hash table over here. Now the solution is we are creating a new hash table with the size of 2x. So in this case we have 4 elements over here. When we create a new hash table, we are going to create with the size of 8 over here. So in this case, in the second hash table, we have 8 cells over here. Now after doing so, we are going to call hash function for these strings over here, and we are going to insert them to this hash table over here. Now here again, we are calling hash function for ABCD. We see that it's returning 2, so we are going to insert at the index of 2. Then we are calling a hash function for EFGH, so the index is 1, so it's going to be inserted at the index of 1. Then we are calling it for IJKLMN, it's returning 3, and we are inserting at the index of 3. Then we are calling it for NOPQ, and the index is 0, so we are inserting at the index of 0. At the end, we are calling it for RSTU, and it's returning 1, and we are inserting at the next empty cell in this case, in case of open addressing. Now we are inserting at the index of 4 over here. Now here, if you don't understand how we are inserting this RSTU at the index of 4, we are going to discuss it in our next lecture, so you will understand the logic behind open addressing technique. So with this, we have come to the end of this lecture. So in this lecture, we have discussed what happens if the hash table is full in case of open addressing. Now in the next lecture, let's learn 3 types of open addressing one by one and implement them in practice, and we are going to implement this case in which hash table is full. So see you in the next lecture.